A count-up function counts from 0 to a preset value and then changes the output from off to on. The counter has two digital inputs, CU and R. CU is the count up input. Transitions from 0 to 1 are counted by the counter. R is the reset input that when switched on will return the count value back to 0. PV is the preset value, which is an integer that the count value will count up to. CV is the count value and displays the number of counts that the counter has currently counted to. Q is the digital output that will switch on when the count value reaches the preset value. When the count function is first encountered, the count value is 0 and the output is off. Each time the count up input switches on, 1 is added to the count value. When the count value equals the preset value, the output will switch on. If the reset is switched on, the count value is reset to 0 and the output will switch off. If the count value hasn't reached the preset value and the reset is switched on, then the count value is reset to 0. The count value will continue to count up past the preset value if the count up input is switched on further. Create a new section and place a counter on the screen with the connections as shown. Use the Exercise 3 screen to test the operation of the count up function. Press the trigger button 5 times. Each time you press the trigger button, what does the count value do and what does the output do? What did the count value CV start at? Press and release the reset button. What happens to the output? What happens to the count value? What happens if you press the trigger button more than 5 times? A countdown function counts down from a preset value to 0 and then changes the output from off to on. The counter has two digital inputs, CD and LD. CD is the countdown input. Transitions from 0 to 1 are counted by the counter. LD is the load input that when pressed will load the preset value into the count value. PV is the preset value, which is an integer that the counter will count down from. CV is the count value and displays the number of counts that the counter has currently counted. Q is the digital output, which will switch on when the count value reaches 0. When the countdown counter is first encountered, the count value is 0 and the output is on. When the trigger button is pressed, 1 is subtracted from the count value. If the load button is pressed, the preset value is loaded into the count value and the output will go off. Each time you continue to press the trigger button, the count value decreases by 1. When 0 is reached, the output switches on. If you continue to press the trigger button, then the count value will go negative and the output will stay on. Place a countdown counter on the screen with the connections as shown. Use the Exercise 3 screen to test the operation of the countdown function. When you first run the program, what is the value of the count value and the output? What happens if you press the trigger button? Press the load button on and then off. What happens to the count value and the output? Press the trigger button 5 times. Each time you press the trigger button, what does the count value do and what does the output do? What happens if you press the trigger button again? The PLC contains system bits and words that indicate the state of the PLC. They will have a prefix of %S followed by a number for bits and %SW followed by a number for words. You can refer to the help for more detail on what is available. One that we will look at is the first run bit, %S21. When the PLC runs for the first time, this bit is set on and thereafter is set to off. Modify the countdown counter that you did earlier so that there is a contact in parallel with the load contact. Label this %S21 and then build and run the program. You will notice that when the program starts, the count value is loaded with the preset value and the output is off. This is because the first run bit is on for the first cycle, which is going to perform a load operation, and then off for the rest of the program. This is the countdown counter in function block using an OR gate. In the last video we asked you to save a program. The program controlled 2 outputs in a 20-second cycle. It consisted of 4 sections. It started with a start-stop section. That section controlled a free-running timer that had a variable called sequence that would count from 0 seconds to 20 seconds and then repeat. There was a variable free run that would turn on and off at the end of the timing period. There were 2 sections that controlled the 2 outputs and turned them on at the right time periods. Modify the program so that it will complete 2 cycles when the start button is pressed and then stop. It will be ready to start again when the start button is pressed again. Use the exercise 2 screen to test your program. Does the sequence start when you press the start button? Does the sequence stop when you press the stop button? Does output 1 switch on and off twice? Does output 2 switch on and off twice? Will the program restart if you press the start button? And save your program.